Hey there. Today, we're going to talk about a fundamental AI concept that you're probably already using every single day, maybe without even realizing it. It's a method for solving problems that is, believe it or not, as powerful as it is simple. Okay, let me ask you something. When you're faced with a puzzle and you just don't know the answer, what do? I mean, think about it. A riddle, a tricky brain teaser, or even just trying to remember an old password. What's your first move? You just guess, right? You take a shot, see if it works, and if it doesn't, you try something else. It's a supernatural human thing to do. Guess, check, and try again. Well, congratulations. It turns out you've been using a core AI search technique your entire life. That simple, intuitive process actually has a formal name in computer science. It's called generate and test. And that same basic logic is behind everything from a spell checker suggesting corrections to scientists generating and testing new medicines. So, how does this really simple human idea get turned into a powerful algorithm? Let's break it down. At its heart, it's really just a simple two-step dance, a loop between two parts working together. This is literally the simplest of all the heuristic search methods. You can think of it as the absolute foundation. Before you can build more complicated AI, you've got to understand this basic idea. One part generates possibilities, and the other part checks if any of them are the right answer. And it's just a relentless cycle. The generate part keeps cooking up potential answers. The test part takes each one and asks a really simple question. Is this it? Is this what we're looking for? If it is, great, we stop. If it's not, we just toss it and go right back to step one. Generate, test, repeat, over and over again. Now, this sounds pretty good in theory, right? But let's put it to the test with a real challenge, because this is where we're going to see both the power of this method and its biggest, most glaring weakness. So here's the challenge. Imagine we need to crack a 3-part digital lock. Each part of this pin is just a 2-digit number, so it could be anything from 00 all the way up to 99. We're going to let our generate and test algorithm have a go at it. So for that first part of the pin, there are 100 possibilities, the numbers 0 through 99. Simple enough. Our generator would just start guessing, 00, 01, 02, and just work its way down the list. But as soon as you add that second part, the numbers really start to multiply. You have 100 possibilities for the first part, and then for each one of those, you have another 100 possibilities for the second. That's 100 times 100, which gives us 10,000 possible combinations. And this is where we really see the problem of scale. When we add that third part of the pin, the number of solutions just explodes. It's 100 times 100 times 100 again. That gives us 1,000,000 unique combinations to test. In computer science, we call this exponential growth, and it can get out of hand fast. So let's imagine our computer is working around the clock, just generating and testing 5 possible pins every single minute. How long do you think it would take, on average, to find the right one out of that 1,000,000 options? 10 weeks. Can you believe that? This brute force approach, just guessing every single option one by one, is incredibly inefficient for what seems like a simple code. So, does that mean our simple algorithm isn't so great after all? Well, not exactly. So is this method just useless for big problems? No, not at all. It just needs a little help. It needs a game changer. It needs what AI researchers call a heuristic. So what in the world is a heuristic? It's basically a smart shortcut. It's a piece of information, a rule of thumb, some kind of knowledge about the problem that helps guide the search. Instead of just guessing randomly, we can now make an educated guess. This is the game changer. What if we get a hint? What if that hint is that all 3 numbers in the pin are prime numbers? This single piece of information, this heuristic, completely transforms our problem. We're no longer looking at all the numbers from 0 to 99. We're now only interested in the prime ones. And just look at what that does to our search base. Between 0 and 99, it turns out there are only 25 prime numbers. So instead of 100 options for each part of the pin, we only have 25. Our total number of combinations drops from 1,000,000 all the way down to just over 15,000. That is a massive reduction. And this is the power of an informed search. What was going to take us 10 weeks of brute force guessing can now be solved in less than 2 days. It's the same algorithm, the same guessing speed. The only difference was one simple, powerful hint. Which brings us to our final and maybe most important takeaway. The generate and test algorithm is simple, sure, but it's not stupid. Its effectiveness depends entirely on how intelligently we design the generate part of the process. So, what makes a generator truly effective? It really comes down to these three things. First, it has to be complete, which is just a guarantee that if a solution exists, the generator will eventually find it. You won't miss the answer. Second, it needs to be non-redundant. This is just about efficiency. Don't waste time checking the same wrong answer twice. And most importantly, as we just saw, a great generator is informed. It uses those hints, those heuristics, to make smarter guesses first, instead of just guessing randomly in the dark. And that leaves us with a final thought. The difference between an impossible problem and a solvable one often isn't a more complex algorithm, but just a better hint. It makes you wonder, what challenges are we facing today that are just one clever heuristic away from a solution? Thanks for joining me.